Hello and welcome to Recording 1D in our series on trigonometric ratios of any angle, Unit 2, Chapter 2, Trigonometry, Mathematics 2200. We'll focus on finding a trig ratio or trig ratios given another trigonometric ratio. Recall, given a point on the terminal arm, the sine of the angle is y over r, the cosine of the angle is x over r, and tan of the angle is y over x. Applying that in this example, we're given that cosine of theta equals -3/4. We have a terminal arm in quadrant 3. What are the exact values of sine theta and tan theta? We begin by sketching a set of axes very quickly like this. Place a terminal arm, just a rough guesstimate as I call it, and remembering we're rotating from standard position, and we drop our perpendicular to the x-axis. The cosine of theta, we're told, is -3/4, which is x value divided by r value. So our x value must be 3, r value must be 4. But hang on, that 3 is on the negative part of the x-axis. So we have a negative value for x. R is always positive. We need to figure out the y value here. Pythagorean theorem says -3 squared plus y squared equals 4 squared. -3 squared is 9 plus y squared is equal to 16. Subtracting 9 from both sides, we've got y squared equals 7, which means y is equal to the square root of 7. But again, hold on. In this quadrant, our y value must be negative. That's important. So we use a -√7 in this case. Now we know that the sine of theta is equal to the y value over the r value, which is -√7 over 4. And the tan of theta is your y value over your x value, which will be -√7 over -3, but we can write that as √7 over +3. Because it's a negative divided by negative. On to the next example. Similar to the first one, we're told the terminal arm again is in quadrant 3. So we'll sketch a terminal arm there. Rough guess. Angle of rotation goes from the positive x-axis. Tan theta, 1/5. Which is your y value divided by your x value. So our y value must be 1, our x value must be 5. But hold on, in this quadrant, these two values must both be negative, which makes sense. A negative divided by negative is a positive. So we've got to figure out the r value by using our Pythagorean theorem again. -1 squared plus -5 squared equals r squared. That gives us 26 equals r squared. Square root of 26 equals r, which is always positive. Therefore, sine of theta is equal to your y over your r, which is -1 over √26. And the cosine of theta, x over r, which is -5 over √26. On to our final example. Suppose theta is an angle in standard position such that cosine of theta equals -5/12. Determine all possible exact values of sine theta. Interesting. We are not told the quadrant for the terminal arm this time. But you may remember our earlier recording on the cast rule. cast, C-A-S-T. Our cosine value here is negative. So we need to find quadrants where cosine values are negative. Well, in quadrant 4, cosine values are positive. All ratios are positive in the first quadrant. So cosine could be negative here. We could place the terminal arm in this quadrant. And it could be negative in the third quadrant. So our cosine of theta is negative 5 over 12, which is x over r. So we have negative 5 for the x side of the triangle, 12 for the r side. Y, we don't know its value yet. But I'll leave a little space there to put it in. In the third quadrant, the r value is still 12, the x value is still negative 5, and we don't know the y value. You pause and do the Pythagorean theorem now, and compare it to my work in a moment. Okay, I've done the Pythagorean theorem work. Negative 5 squared plus y squared equals 12 squared. Working it on down, you get two possible values for y. Positive square root of 119 or the negative square root of 119. The positive one goes in the second quadrant and the negative one goes in the third quadrant. That gives us enough information to find the possible exact values of sine theta. So I've quickly done those here. Sine theta in quadrant 2 is positive root 119 over 12. And in quadrant 3, it's the negative square root of 119 over 12. In conclusion, to determine the value of a trigonometric ratio when given the value of another ratio, determine possible locations of the terminal arm. If you're not told the quadrant, use cast. Use the appropriate relationship to determine the lengths of two sides of the reference triangle. Use the Pythagorean theorem as necessary. Then determine the desired trigonometric ratio.